Hi, my name is Cliff Patterson, and I'm a senior GIS consultant at PSD in London, Ontario. And welcome to my talk called Leveraging PostGIS in an Enterprise Environment. I work at a company called PSD. We make a piece of software called Citywide that's used by a lot of public sector organizations. We have a research and a consulting and a software division. The software division is where I work, and we use PostGIS throughout our organization. PostGIS lives here within our asset management team. Our consultants use it regularly to do analysis. They do GIS analysis using it. They store a lot of their data within a PostGIS database when they're working with it to deploy it to our software. Our enterprise asset management system also uses PostGIS, Postgres and PostGIS. And the enterprise GIS platform that I develop and maintain it uses PostGIS as its core spatial database. So I'm going to start with just a basic introduction of PostGIS as a spatial database. So before we begin, I just want to say that the target audience for this is really anybody who has knowledge about GIS application, concepts, and analysis, maybe some basic SQL skills, but has limited to no experience whatsoever using PostGIS. So if you're a PostGIS pro, this is probably going to be boring. If you know nothing about it, this is probably going to be very helpful. So this presentation will not cover things like setting up the PostGIS server, setting up the server OS, installing PostGIS, and all of that garbage. But I will be using a lot of data in this. I will be just referring to stuff. So if you do want to get your hands on it, you can tap into it at the Windsor, Ontario Open Data Catalog. Great data sets in there, including all their parcels, their roads, their sewer systems. Really good data set to have if you just want to tinker with this stuff. So what is PostGIS? Well, PostGIS is Postgres, or PostgreSQL, is an open source relational database management system. It's comparable to something like Oracle or SQL Server, but PostGIS is an extension to PostgreSQL. It is comparable to something like Oracle Spatial or some of the SQL Server spatial data functions that are available. It allows users to work with spatial data within a relational database management system. So we often say that PostGIS is a GIS in a box. PostGIS has specific spatial types like geometry and geography. It has custom spatial indexes for spatial data. It has spatial functions, a list of these that really gives you access to every single tool that you would normally use within a desktop environment. But one can also use all of the Postgres types, indexes, and functions. So problems with file-based systems, I call them JBoss systems, just a bunch of shape files. You have decentralized data that leads to duplication. You have a lack of data integrity, no control over transactions, no roles or permissions, a clutter of intermediate data, no data relationships, limited ability to collaborate, limits on file size and field lengths with shape files, and you end up with file folders that look like this. It's chaos. So one of the advantages of a spatial database over a file-based system is that you have a central point of truth. All your data is centralized within the database system. That leads itself to data integrity, and you have transactional control. You can control who can read and who can write certain tables. That gives you an incredible amount of security. You can lock down your data. It's reliable. It's scalable. You can access support for this database through third-party companies. It integrates with third-party apps, like think of it a WebGIS, or if you want to create an API to run certain analysis on your database, you can do that. You have roles and permissions, so you can create, you can refine the access to the geospatial databases. And the best part is that you have no intermediate data clutter, as long as you haven't given users the ability to basically create whatever they want within the database. You're not going to have that clutter that you're going to find within a file-based system. So I'm going to dive into roles and permissions and how to secure your spatial database really quickly. So the first thing is you want to create your roles and permissions. So a to-do list when I'm setting this up is I create one database for all. I create various schemas. They're usually thematically organized. I create group roles for different departments or divisions within the organization. I create a general all-purpose read-only group. I grant connect on the database to each group role. I grant usage or all on each schema where appropriate for each role. And for each table within each schema, I grant either read-only permission to each role, or I grant all if they're allowed to edit it. And I create a bunch of users in the end, and I grant membership to the various roles. So what this kind of looks like is that if I created a database called GIS, I would create a bunch of schemas within that database: boundaries, maps, parks and rec, services. And then I'd create a bunch of roles. So I'd create a read-only role that had, and notice these are no login roles. So the read-only role and the editor role. And then I'd throw some data into the database. So I'd put electoral wards into boundaries, parks into parks and rec, and fire stations, hospitals, and police stations into services. The next, I would grant access. So the first step is I would grant usage on the schemas to the read-only role. I would grant read-only permission to view each table, so everybody who's a member of the read-only role would have the ability to select to read these tables. But then I would also have one table, let's say the parks table, and I would grant all on the sequence to the editor. The editor needs access to the sequence to add new rows to that table. And then I'd grant all on the table also to the editor so that they could edit it, create rows, add, delete, truncate, whatever they want to do. And then the final step is creating the users. We create Bob. Bob we don't trust too much, so we grant Bob the read-only membership. So Bob can only log in and see all the data that we allow the read-only group to see. Sarah has all those rights. We grant read-only to Sarah, but we also grant editor to Sarah. So that parks table that we're allowing to be edited, Sarah can now edit it. And that's pretty much it. We've created a relational database. We've created a bunch of schemas. A bunch of tables are within that. And we've controlled access through the permission system. Okay, now I'm going to run through some of the basic PostGIS queries that you can run, or as I like to call it, 80% of the stuff that most techs do on a daily basis. So let's just start with creating a table. This is pretty much the first step. We're going to use the create table command just like we do in a normal database, but you'll notice that we have a geom field, which stands for geometry. And within this field, there are two main sort of data types, the spatial data types that we can add. It's either geometry, which is a data type that uses a planar coordinate system for measurements, something like UTM, and it has many functions within PostGIS that can be used on this. Or we can also use geography. So geography uses a geodetic coordinate system with calculations on either a sphere or spheroid, and this is something like WGS 84. And there's a limited number of functions that can be used on geographies. But the neat thing here is that we can also cast from one to the other, right? So if you do have a data set that's all in WGS 84, you can cast it to geometry, and it will look and act and feel like a data set that is in UTM. The other important thing here is to know really the geometry type that you'd like to create. So is it going to be a point, a line string, a polygon, and all these can be used within PostGIS, a multi-point, a multi-line string, a multi-polygon, and the list goes on, especially once we dive into things like 3D data types. But this is it. This is the first step when using PostGIS, is creating these tables. You can also import. So if you look at QGIS, has a number of functions that allow you to import existing like shape files or geopackage layers. You can import those directly into PostGIS, and they'll just create a table like this that you can use. All right, next, let's look at the process of measuring a single 2D geometry. So we might ask questions like, how long is a specific road segment? There's a function in PostGIS for st length. It takes the geometry in and it spits out the results. So this is what the query would look like. Select ID, ST length, you're going to put the geom field, so that's the field within your database from some specific schema and table, where the ID equals 923 or whatever it may be. And this will give you the ID as well as the length of that geometry. So what is the perimeter length of the park? Well, exact same thing. We have a function for st perimeter, and this will give you the perimeter of the geometry. If you want to know the area, you guessed it, there's a function to do that. And it's st area, and it takes the geometry and it's structured the exact same way, and it will give you the area of the park within that coordinate system. So if you're using UTM, you're going to get the results in square meters. Okay, so I just want to show you how using st area can work within QGIS specifically. So let's say we want to get the area of Ward 4. We identify and we see that the ID is 2. Okay, so this is the area we want to get. So we put that into the statement where we're just doing st area, calculating the area for the municipal electoral wards where the ID equals 2. Run this and we get the area in square meters. Easy as that. So what if we want to determine the coordinates of a geometry? Well, fortunately, there's a lot of tools within PostGIS, a lot of functions to do this as well. So what are the coordinates of the broken street lamp, we might ask? Well, there's a function called stx and sty that both take the geometry, and we can run a query like this, and what will come out is an ID field, a coordinate for your x, and a coordinate from your y that come directly from the geometry. So if your geometry is in UTM, the coordinates coming out will be in the same coordinate reference system. So what are the coordinates of the start and end of the trail? There's some neat functions like st start point and end point. Both take the geometry, and you can get the coordinates for the start and the end of a line segment. And the statement would look something like this, where you're going to use stx and sty. You're going to use also st start point and end point to get these coordinates. And you can also get the coordinates of a centroid. So you can ask questions like, what are the center coordinates for the park? And you can use a function called stcentroid that takes the geometry, and you can use stx along with stcentroid, put the geometry in there, and you'll get the x and the y coordinates for the centroid of the park. But what if you want to transform this? What if the coordinate system that the layer is in is not the one you want to actually spit out? Well, fortunately, you can easily transform to and from different SRIDs within PostGIS. So you can ask the question, what are the coordinates of the broken street lamp in WGS84? And again, we're going to use stx and sty, but you can also now use sttransform. And sttransform takes the geometry and the SRID. Right? So you can put the SRID in there. So if you want to transform it to WGS84, you can transform it to 4326. So it's as easy as that. You wrap the geometry within your queries, or the geom field, wherever it appears, wrap it around the function sttransform with 4326 thrown in there, and the coordinates that are going to come out, now you're getting lat longs coming out of this. And you can do the same thing for the start and the end of a trail, and you could just have to add. The font size starts to get a little small as these queries get a little more complex. But you can see that we add the sttransform in here, we transform it to 4326, the coordinates come out in Latin long. Again, likewise with the stcentroid, you'll get the same coordinates in 4326, and that's pretty much it. You can transform to anything you want. As long as you know the EPSG number, you can transform it into whatever coordinate system you wish, as long as it's supported by PostGIS. Okay, so I just want to show you how it works within QGIS. I have the database manager opened up, and we're looking at, we're going to run this on a layer called trail within this transportation schema. And this is just the query to generate the start points and the end points for this single line. And when we run it, we can see that we get the lat longs for both, and it's as easy as that, just to generate the coordinates. And of course, if we took off the st transform function, the result that would come back would actually be in UTM coordinates. Okay, so next we're going to look at doing sort of a nearest neighbor analysis and looking at distance a little bit more. So we can ask questions like, what is the nearest storm manhole on George Street? And this would be within Windsor, Ontario. So you'd run the query, select everything from the storm manhole tables, and then we're going to use order by st transform. We're going to transform one of those data sets that is not in 26917, the UTM coordinate system, and then we're going to compare it to the street center line. So in this function, the storm manholes are actually in 4326, so we're going to transform those to 26917, and then we're going to compare the distance between the two to find the closest one. Now the neat thing here is that you're going to notice this little nifty operator right here, and this is an operator that does 2D distance comparison between two geometries. And there's a bunch of these within PostGIS. There's a bunch of distance operators that can be used. And using it within an order by substatement will allow you to compare the distance between two layers. So when you run this, you're going to get back everything, the nearest manhole closest to this street, the street that has an ID of 1523. So this is a really, really easy and fast way to run this type of nearest neighbor analysis. So in this next example, we're going to use that nearest query that we built to find the nearest storm manhole to a specific street center line. So first, let's get the ID of the street center line. So we're going to use Argyle Road right here. Actually, we're going to use this segment right here, which is 2006 is the ID. So let's look at DB Manager, and we're going to put as the ID here 2006, and we are going to execute this query. Now we're going to load this as a new layer, and if we load it and move this away and zoom in, we can tell that this is actually right here. The 2R931 is the closest storm manhole to Argyle Road. So that's a really quick example, just showing you how you can use this, how quickly you can identify a feature on the map, create your map from this, or send those coordinates out to somebody working in the field. It's as easy as that. All right, another thing that you might do quite often is create new geometries in order to run your analysis. One common task that we all do might be just creating random points, random sampling points. So in this, maybe we have a certain ward boundaries and we want to create 1,000 random points, and we're going to be doing some sort of sampling with those points, maybe in imagery or something like this, right? Fortunately, within PostGIS, there's a function called stGeneratePoints. It takes a geometry and an n value, so the number of points that you actually want to generate. And it's very simple, right? So you do select stGeneratePoints, geom, call the results geom, so that column has an appropriate name. And then from boundaries.municipal electoral ward, so if we have our ward boundaries, and then we want to select one specific ward. So ID equals 1, and then what the result of this will be 1,000 points generated within that ward. So really easy stuff, but sometimes there's other things we want to do, right? So we might want to determine what is the nearest storm manhole to specific coordinates. Maybe we have somebody out in the field collecting GPS points, and they want to know, okay, what is the closest manhole to where I'm standing right now? Here are the coordinates in UTM, go. What's neat is that you can use stMakePoint, and you can also use the stSetSRID, and that's going to take the geometry and the SRID number that we're going to throw in here. So we can do select star from public works, storm manhole S, and we're going to order by, and this is the same distance calculation, but you'll notice the big difference here is that we're not doing the distance between two existing tables. We're looking at the distance between an existing table, storm manhole, with the ST set SRID, and the point that we're creating. So we're using the st make point function with the coordinates that we have. And notice we're using 26917, which is UTM. So now we're comparing apples to apples in terms of coordinate reference systems. And we're going to be able to determine the closest one from this. And you're limiting it to one, so you're going to get one result that comes out of this, which will be the closest manhole to this location. So these are just a couple of ways that we can create different types of geometries, but we can create other types. So there's other functions to create things like make polygon or make line. And for whatever we need for a query, we can create those geometries simply from coordinates. So this is really a helpful feature, especially if somebody's going to hand you some GPS points and want you to run some sort of analysis on it. You can write up these statements and run them quite easily without having to like import data into the database. You don't have to create a point data set that has one point in it. You can just put it within the query itself and run it. Really handy stuff. So generating random points in PostGIS is actually quite easy. We saw this from the query, is that we use the st generate points query, and we're going to run this on the wards boundary file where id equals 1. So let's just run this. It creates a geometry. We load it directly into the map. And if we look at the map now for ward 8, we have 1,000 points within this boundary. I'm not going to count them. You can believe me on that. But yeah, and again, really fast to generate. And now we have all these sampled, these points that we can use for sampling. So, very fast, very efficient. And it's just, a couple of lines of SQL to get this done. Okay, let's dive into spatial relationships. This is really the bread and butter of any GIS task, is comparing one geometry from one layer to the geometry of another layer. So show me all parcels within ward number 8. And we can use st-intersect. So this runs an intersects analysis on two geometries, G1, G2. So look at this function is that we select star from the parcels P and the wards W, and we where, and in the where clause we say st intersects, and we transform one of the geometries to 26917 because the other geometry is already in 26917, and we say one specific ward, and we just want to count the number of parcels, and this will output every single parcel, all the fields. Now if you modified the select and just added something like the count aggregate function, you would just get a number, and you'd find out there's 3,000 within this ward, let's say. So what parcels are within 1 kilometer of fire hall number 1? And here we can use the std within function, which takes two geometries, geon1, geon2, and a radius. So it looks something like this. So in the where clause, we're actually going to use std within, and we're going to transform one of the geometries so that everything is apples to apples, and we're going to select the geom from the fire stations where id equals 1, and then the third input into that function is the 1,000, which is a kilometer around each one, and you're going to then get all the parcels just around this fire hall. Now, this will look quite familiar to the spatial relationships in a QGIS tool like select by location, where we have intersects, contain, disjoin, equal, touch, overlap, are within, cross. And guess what? You can do all of these within PostGIS, right? So these are all functions that you can run on two different geometries and get something out of it. Right, so to run this type of analysis directly in the database, you don't have to create intermediate data. You don't have to take these tools and then run these tools within using a QGIS tool. You can run this directly within PostGIS as a statement and get your results. Really powerful stuff. But this is really just the tip of the iceberg as to what you can do with spatial relationships. The big thing you can do, SD crosses as well, but the big thing you can do are spatial joins using these spatial relationships, right? So you can create a list of all fire stations and their associated wards using something like st contains, right? So the fire stations are, of course, a single point file, and the wards are a polygon. So you can select everything from them using the ST contains, but notice we're doing a join, and we're doing a join on ST contains with the two geometries. So a note here is that the spatial relationship is the foreign key. Normally when we relate two tables together, it's because they have a common field, and that's the foreign key, and the number will be, the integer will be the same in both, and you can connect those two tables and they're joined. In this case, the spatial relationship with a spatial database, that is the foreign key. So it can be used with any function that provides any type of true-false relationship for two tables. Now, most commonly, you'll see this being done with st intersects, st contained, std within. But this is used quite commonly. This is really my bread and butter when I'm using PostGIS, right? Is creating these relationships between tables, drawing together data. You could have something like, if you could imagine having something like a forestry layer, and you could calculate the amount of forest within a certain ward using a join like this. Really neat stuff. So here's the example of doing the spatial join within QGIS's DB manager. So this is the statement that's basically looking for the counselors, right? It is sort of adding the counselor, the ward number to the fire station layer. So it's just joining both of the layers based on an ST contains spatial relationship. So if we run this, we now get the ID, we get the geometry, we get the address, we get the fire hall. This is all coming from the fire stations, but we're also getting the ward number, which is just the number, and the counselor associated with that ward. So again, very easy to make that relationship between the fire halls and the ward, and of course we could use ST intersect. We could use a variety of different functions to create this relationship. So next, let's look at combining geometries. Oftentimes when we're running analysis where we'll want to combine two different geometries in order to do some sort of buffer analysis or to just calculate an area from a variety of sources. So we can do this quite easily in PostGIS. So we can ask questions like, what is the area served within 500 meters of fire hall number 1 and the Windsor Police Headquarters? So we can use ST union with two geometries. That will union the two geometries into one. So with select ST union, we're going to also use another function, ST buffer, which does exactly what you think. It takes a geometry and you tell it how much you want to buffer that geometry by, and it will run that analysis for you. So we're going to do an ST union on the buffer geometry of the fire stations and the buffer geometries of the police station. We're going to union those, and we're going to create a single geometry. And we're also going to say, we want a specific ID for both the fire stations and the police stations. And the result of this is a single geometry that merges those two buffers together into one. So there's other things we can do in terms of combining geometries. We can also ask, what is the area not served within 500 meters of Fire Hall number 1 and Windsor Police Station headquarters within Ward 3. So we can use ST difference. And again, this takes the first geometry and the second geometry. And you'll see here it's a little bit different than the previous one, is that we're going to take the geometry of the ward and we're going to run the sort of same ST union, but we're going to wrap that around ST difference. So this will create the inverse of that union. So as opposed to just unioning the two buffered areas together, you're now going to be doing the difference between the two. And this is really a great tool, especially if you want to ever take the inverse of a buffer in a simple analysis or something a little more complex like this. Very handy to have. Okay, so I'm going to show you what we're trying to do here. Is that we're basically trying to say what area is not within 500 meters of either the Windsor Police Headquarters or Fire Hall number 1. And we saw this in the slides as we're using the ST difference on the union of a buffer between those 2 points. And then we're also going to do the difference between that and the geometry of the ward boundaries. So when we run this, We get one geometry, we load it onto the map, and then this is what we end up with. And it's exactly this. Now, with this, we could run, we could add to this query and do like an ST intersect on this and find all the parcels that are further than 500 meters from this center point. You could write that query in a variety of different ways, right? But at least this is, if you needed to create a map that just said, you know what, I want everything that's 500 meters away from, further than 500 meters from these two points on the map, this is the way you'd be able to do it. And it's very quick, very easy. And there's no intermediate data, of course. Like, you're running all this within the database. So even the query layer that loads within QGIS, that's just a temporary layer. When you remove it, it's gone. There's nothing left over. So this is something that I use quite often. This type of analysis, you'll create a point in the middle. You want to use ST difference to, it's sort of like almost like doing like a reverse buffer analysis on points when they're within polygons. So yeah, very handy stuff. Okay, now that we have the basics under our belt, one of the things that I love most about PostGIS, and it's really a PostGIS function, is that we're able to create trigger functions. And we're able to trigger those whenever we add a new record to a table, or we update a table or delete a table. And what this really does, this really makes the database work for you. So this really comes back to what I said earlier, is that if you have to do anything twice, you should script it in some way so that you don't have to do it twice. So I'm going to show you just some basic ways of which you can do this within the database. So a basic trigger function. And I'll flip over into QGIS after this and just show you what this actually looks like in the desktop environment. So we want to calculate the area of a polygon when it is created and updated. So we create a table, a polygon table, and we create a function, and the function is called polygon trigger function. And basically all it does is it calculates the area in square meters for the geometry. Notice that we're casting it to numeric, and we're wrapping it around the round function. We have to cast it to numeric in order to use the round function, and we're going to have 2 decimal places. So we're using the st area function here with the new geometry. So that is the geometry that's created as we add a record to the table. So we've created this function. At this point, it does nothing. We want to actually create the trigger itself. So we create the trigger called polygon trigger, and it is triggered before insert or update on the test polygon table for each row. And whenever a new row appears or is updated, this function, this function that we've created here, is triggered. So I'll show you in QGIS what this looks like. So in QGIS, it's pretty straightforward, right? So we have this polygon table that we just created. We're going to create a new polygon. Right click, notice the area, square meters, it is empty. There's nothing in here. You could put something in here if you want, but the minute you press save, that is overwritten. It's overwritten with the trigger function. So now if I click on this, we're going to see that we have the area in square meters here. Now, even if we edited it and we said, no, I want it to be 999, and press OK and press save and turn the editing session off and go back and identify that feature, again, it switches back to the same old value. And again, if we go in and we say, no, I'm going to edit it and I'm going to change it now, and press save, turn off the editing session, go back in, identify that feature, again, we see it's changed, right? So on update, on create, that area in square meters is going to change. And this just makes trigger functions such a handy tool because, again, it does the work for you. And you don't have to actually run these functions on a table or do the whole create a new column and calculate that whole column. No, this will just do it for you every time you make a change on that table. Really handy stuff. Okay, so now let's create a trigger function that's a little more complex. That's kind of more like a planning tool, right? It does a whole bunch of stuff for you, so you don't have to run any analysis. You just create a polygon. It does what you need. So we're going to ask questions like, in what ward is the proposed park located? What is the area of the proposed park? Which police and fire stations will serve the proposed park? And how far are they, at least as the crow flies? And how many parcels are within 1,000 meters of the proposed park? Because that'll tell us sort of how many households are around here who will actually use this park. So we're going to create this table, fairly simple. We have a bunch of fields for everything that the trigger function is going to throw out at us for the ward, the nearest police station, the nearest police station distance in meters. Yes, we can have field names this long. This is one of the wonders of a database. And the parcels within 1,000 meters. So the trigger function that we're going to create is quite complex. So we're going to add the area that we did before. We're going to add the ward, and the ward is just a select intersects analysis. The nearest police station is that same sort of distance distance statement that we saw earlier. The distance in meters uses the stdistance function within PostGIS to calculate the actual distance in meters, and so on. And we repeat that for the fire stations and the parcels. The parcels, we run an st intersects analysis on that, but we do have to also include an st transform on that parcel layer, because we know that the parcel layer is actually in 4326, EPSG 4326 for some reason. And we create the trigger. So now let's look in QGIS on what actually happens when we create one of these polygons. Okay, now within QGIS, we can look at this new parks table that we created. And you see it right here. We're going to edit. First, let's zoom in. And let's say that this area right here is an area where we can put a proposed park. And I'm just snapping to the roads here. I create this. And we see we have all these fields. We have the area in square meters. We have the ward. We have the nearest police station, and so on. Nothing is populated. When we create this, we don't need to add any values whatsoever because the trigger function will do all that work for us. Saving takes a few extra seconds because it does a little bit of extra work for us. But when we click on this, now we see that the area is calculated. We know which ward this proposed park is located within. We know the nearest police station. We know how far it is. It's about 2.3 kilometers away. The nearest fire station is fire hall number 1, and that's about 1.6 kilometers as the crow flies. And we know that there are about 5,051 parcels located within 1 kilometer of this proposed park. So likewise, we could go into another part of the city, and we could say, okay, well, this looks like a nice place for a park. And we can add this as well. And you'll see that on save, takes a few seconds, comes in, and we get all our values as well. And now we're in Ward 8. The nearest police station is an RCMP branch. The nearest police station is about 2.1 kilometers, and so on. So this is a really neat way of just, making the database do the work for you. So all those spatial queries that I showed you at the beginning of this, you can plug them into a trigger function and have it automatically generate those values for you. Saves a lot of time, saves a lot of repetition. And now you've created something that's really like a planning tool, right? So if there's 5 or 6 or 10 different locations, basically all you have to do now is just go on the map, create a few different polygons, export that table, and you've just handed data over to somebody to work with who might be making a decision based on that. So really handy stuff and really helpful. Okay, so we came to the end. I don't expect that anybody is going to take all this in if this is entirely new to you and be able to sort of go with it. But this was just really an effort to sort of break the ice into the world of PostGIS. I'd like to point you towards the documentation. The PostGIS documentation online is superb. Very thorough. Also, really, honestly, anything you search for, you're going to find somebody who's asked the same question online, and you're going to be able to, pick up a lot of materials from that. There's also great videos online. There's great books. Tons of material on PostGIS if you really want to learn a lot more. So I'd just like to, before I end, I'd just like to give a special thanks to Steve for organizing the conference, Crunchy Data for organizing the PostGIS day this year. Paul Ramsey for supplying me with some materials that he uses for his intro sessions that I used quite a bit. And Jessica Kane for collaborating with me on setting up these two intro sessions for this day. So thanks a lot, and I'm open to any questions.
Okay, welcome back. If you want to ask questions now, you can either raise your hand or you can put it in the Q&A. There's been quite a few questions asked in the Q&A and answered. Cliff and Paul have also been quite active in the Discord area.
Yeah, and I just uploaded my slides actually to Discord too. So if anybody wants to see any of those queries, it's a PDF, so you'll be able to sort of copy and paste.
Thanks, Cliff. I'm going to download those now, and we'll see if we can find a way to host those later for everybody else as well. Is that okay with you?
Yeah, that's perfect. Do it. Usually I put it on GitHub when I'm done, but I've been, haven't been 100% in the past couple of days. So
okay, not a problem. Anybody have any questions? Or Cliff was absolutely, well, there was a lot of questions already, but any new questions, I should say.
I left all the projection stuff for Paul.
Yeah, exactly. That's, yeah. Mm-hmm.
I just didn't see those. I ignored those.
I mean, I think one of the interesting things that Paul has pointed out to me, well, I don't know. I mean, when I'm using stuff coming off of GPS now, I usually use geographies rather than geometries, because most of the operations I want to use are supported, and then I don't have to think about projections and I don't have to think about units. Like, it always comes back in meters. So
right. Yeah,
I really like that. But if I was working for a town planning agency or something, there'd be no way I would be using geometries.
Yeah, I actually had one case where when I was flying drones at my previous job, I had to submit coordinates in degrees, minutes, seconds. And there's actually a really cool function that will convert coordinates to DMS. So I created this trigger function that would just automatically produce those coordinates. So when I had to submit like my flight proposal, I would automatically have a label on the field that I was flying over that would have the coordinates in DMS for the centroid. So again, make it work for you, people.
Yeah, I mean, that's the other thing that I think a lot of people aren't used to when they're a desktop GIS user is you can also, I mean, you can do triggers, but you can also, all the questions you want to ask, you can put them in one long SQL file, and you can either copy and paste those SQL queries into the command line client or into DB Manager, or you with the command line client, you can run all those queries and get all the answers you want instantly. So
yeah,
like when that project manager comes to you and say, oh, we just updated a bunch of this. Can you run those queries again? It's not like, okay, well, let me open up ArcGIS Desktop and let me click, and it's just done, right?
Done. Yeah, I always store them. You can actually, in the DB Manager, you can store them in the project, right? So you could just drop down, click it. But the thing is, you have to tell your boss, this is going to take me a few hours.
I think I usually say days.
Yeah, get back to me.
Go on a vacation, and then I come back, and I'm like, oh man, that was really hard work.
That was tough.
Yeah, but I did it for you, and I did it as fast as I could.
Yeah.
Exactly. All right, there's a couple more questions in. Well, no, I think Paul probably answered them.
I like answering questions.
Yeah,
so it's good.
I wanted to add one thing to your talk, Cliff. You gave that neat little planning example.
Wait, Paul, 1 second before you talk. So for those who don't know, Paul will be speaking later today. Paul Ramsey was one of the founders of PostGIS, and he's one of the lead committers. The next talk by Regina Obe is one of the other lead committers. So that's Paul's context for why he speaks, because not everybody knows who you are, Paul, on this talk.
Yeah, I'm just a panelist. You showed the planning trigger and so on, and talked about, then you just add a whole bunch of other parcels and you get out your planning report, sort of looking at it from the desktop context. But the thing that I find really cool or powerful about the way you did that architecture is that you could also have a web app in front of that same trigger.
Yes.
Your boss could add the parcels himself and get the report out of like all of a sudden you're setting yourself up for the self-serve situation because you're not tied to a particular tool for point and clicking. You can move it out to the web. You can move it out to other places. Anything that can connect to the database can ask these questions.
Yeah, yeah, 100% right, Paul. That I think that was one of the things that when I was putting together this talk, I could have, we could have done this over a few hours or days just on these sort of enterprise applications. But that's one of the major points is that you can connect to this database in a variety of ways, right? You can connect to it from a web map. And yeah, I love that idea. You just, have somebody click on a map and it does 10 different things in the back end and then spits out the answers.
Yeah. And I think the other thing that people also forget is that when they do these operations on the desktop client has to, if you had done this operation not in the database, like if you had done your buffer or unions or any of those things in ArcGIS, in QGIS, in any other desktop tool, it first has to take all that data, like all the data across the wire, then make those into objects in the desktop system, then perform the operations in the desktop system.
Yeah.
Right. And so by doing them in the database itself, usually one, database servers are big honking servers, but also two, the only thing you're going to stream back to the client is the results, not and doing all those intermediate and chewing a bunch of memory on the machine. So that's the other reason I really like keeping the analysis close to where the data is.
Yeah, exactly. And I love having no intermediate data. I love the fact that everybody within an organization can run these types of queries, and we're not going to end up with a file system filled with a bunch of clipped and buffered shape files. It's an excellent feature.
Buffer one, buffer two,
one, two, final, no
the real
final,
buffer.
This one.
Yeah, exactly. All right. Well, thanks a lot, Cliff.
Thank you.
I think we have 10 minutes until our next session, which will be Regina Obe talking about new stuff coming in, or has already come, I think, in PostGIS 3.1.